Hello everyone. As we present how Zscaler ZPA Zero Trust architecture allows authorized users to securely connect to private applications, questions that often get asked are what happens under the hood in the ZPA cloud as users connect to applications? How does ZPA Cloud know what's the best app connector to serve the user's request? Where is this app connector located? How to pick the best app connector in case if there are more than one that can serve the user, how to keep track of healthy applications and how tunnels are established, and so on. In this video, I'll present ZPA architecture to address these questions. ZPA model is built on microservices and delivered using API, which is inherently different from ZIA. We see administration interface, operation interface that ops teams use to manage the platform. We publish custom APIs so that the customers can use them to manage the policies, create segment groups and access policies. Front-end APIs to manage the infrastructure and create policy constructs. Similar to ZIA, there is a concept of central authority which ensures consistent configuration access across microservices distributed across globe. Service Edge connects to configuration distribution nodes which distributes persistent configuration from centralized database throughout the cloud. The database and configuration distribution points are located globally for high availability and low latency. It holds the configuration and makes the policy constructs. ZPA Dispatcher is responsible for internal application routing. Dispatcher decides which app connector is best suited to serve the user request. It also facilitates in setting up microtunnels and keep track of healthy apps. Service Edge or broker is the data forwarding node for ZPA system that performs client authentication, connector authentication, configuration distribution to app connectors and client connector, message passing between dispatchers and connectors, microtunnel signaling, microtunnel data forwarding, and logging for all authentication tunnels, microtunnels, and health. Service Edge talks to dispatcher to understand where the applications exist. No traffic flows through dispatchers. They are only used for signaling. Now that we know the role of dispatcher and broker, let's see how they communicate. Every broker maintains a TLS connection with every dispatcher in the ZPA cloud, which results in a full mesh network. Note, as dispatchers communicate with brokers, there is no inter-dispatcher communication. As the app connector is launched, it initializes the service and establishes the TCP control channel to a broker. As the app connector learns the downstream internal apps, it sends a registration message over the TLS connection to the broker, which is relayed upstream to all the dispatchers. Each dispatcher records a registration message from all the brokers and builds an ephemeral map for all app connectors and their downstream applications. It's key to keep track of healthy apps. As we saw in the previous slide, app connector maintains a TLS channel to the upstream broker. App connector issues a health check over port 443, which is then reported to the broker. The broker logs the healthy app protocol information and which app connector reported this healthy app. This data is passed up the broker to all the dispatchers. Every broker has a preferred dispatcher, the one that is geographically closest according to the coordinates assigned in the ZPA's backend configuration. When a user sends a request to access an app, the broker sends a dispatcher request which contains the location of the user as reported by the ZCC, broker location, application ID, port, and protocol requested. In the next step, we'll see how we identify this best app connector suited for the user request. The user sends the request to access an app. If the broker receives a request from the customer not seen before, It fetches the customer policy configuration from the dispatcher and performs the policy evaluation. The broker contacts the geographically closest dispatcher to help identify the app connector. Since dispatcher maintains a complete ephemeral map for all app connectors and the internal apps behind them, it sends a bind request to the app connector's controlling broker, the broker to which the app connector has established its control channel. The broker relays the bind request to the app connector and tells which broker the user resides on and the ID of the microtunnel it needs to complete. The app connector checks the app and establishes the microtunnel to the broker that the user is connected to. To recap the flow we covered, microtunnel is created as the user sends the application request, policies are evaluated, broker sends the dispatch request to the closest dispatcher, the dispatcher sends the bind request via broker to the app connector, and the app connector completes the microtunnel, which is stitched by the broker. So this brings us to our last slide on how ZPA selects the best path. ZPA checks the health data to find the app connector with valid paths that can reach the app. The resulting pool is all eligible connectors that can reach the application at the time of the request. From this pool, ZPA finds the path with the closest geographic proximity to the requesting user. ZPA examines the geographic distance from the user to these eligible app connectors. Distance is calculated from the location of the app connector and the geo IP of the client seen by the broker. ZPA removes all the paths involving a connector with geographic distance more than 200 miles. The resulting pool is all paths involving eligible connectors with app reachability that are within 200 miles of the closest connector to the client. ZPA finds the path with least latency, that is the lowest round-trip time from the connector to the server. For TCP apps, ZPA collects round-trip time between the connectors and the server using a single TCP connection. ZPA removes all paths with latency more than 2 milliseconds greater than the least latency found in the previous step. The resulting pool is all paths involving eligible connectors with app reachability that are within 200 milliseconds of the client and within 2 milliseconds of the lowest connector to the server round-trip time. From those remaining paths, ZPA randomly selects a path. And finally, ZPA creates a sticky cache for this decision, which is valid for 30 minutes from the last access. So hope you find the information presented in this video useful. If you have any questions, feel free to reach out. Thanks and have a great day.